Welcome everyone to another live stream here on our open source low-level overclocking and optimization channel. If you're new to this channel, we are building a whole Linux distribution. Also, I'm live streaming from an Apple Silicon Mac today. T2 Linux, also supporting Apple Silicon ARM64 Linux. And recurring subscribers know, of course, that not only do we like epic and thread ripping, but the only substitute for performance is more performance. So our T2 Linux is already one of the most optimized and fastest Linux distributions out there, supporting everything from ARM to RISC-V, Super H, Spark PowerPC, and x86. And today I finally retested what I had already done 15 years ago, which is optimizing the Linux kernel even more. And I found that simply like setting CFlex to your optimization target, in my case Zen version 3 or so, can improve performance up to 5%, right here, 5 minutes 60 and 10 seconds instead of 5 minutes and 26 seconds. So on the basis it is super simple, right? Just that Linus Torvalds hates this optimization and trick. So time-wise we are speaking, so what we're talking, also this is the wrong one, Linux. So we're talking bringing the Linux kernel build time down from 3 minutes 46 to 3 minutes 43. So basically nearly 3 seconds. With other packages, it's even more dramatic. Clang comes down nearly 10 seconds, building Clang on this Ryzen as setup patched and controlled in the T2 sandbox from 2 minutes 51 to 2 minutes 42, and so like 9 seconds, right? And then with LVM, that is a whopping cutting down 5 minutes 26 seconds to 5 minutes and 10 seconds. Why not? We can actually, to double check, let's also build Firefox just. Actually, no, wait a second. We need to rebuild Firefox. So on the basis, it is super simple, right? So what I've done, not only our smartest optimization of optimizing everything for size or O1, depending on. So basically optimizing everything, not so much, except hot code passes, which we have package metadata of storing pre-benchmarked so that you don't need to do that at home, so that T2 has a database of profiling information on a per file basis of stuff like rsync, GCC and so on. So we do this already, which usually is quite beneficial of keeping code size small and caches filled and utilized and cache hits high. And so today I wanted to re-explore what I had done already 15 years ago, which some other people might also do, basically optimizing the Linux kernel also with march, mcpu equals Zen version 3. And so the Linux kernel does not have provisioning for that. What the Linux kernel does have, so for example, for Spark 64 even, I noticed that the other day. So why do I even come back to this, right? This is the recurring theme. The other video the last videos live on this channel, I played with epic, thread-ripping, embarrassingly parallel, multi-threaded PowerPC and Ultra Spark hardware. Previously 20, if not $40,000 worth of equipment. Of course not anymore. And I noticed for Spark 64, the Linux kernel has even, like nobody is using except enterprise people like us. But so the Spark 64 kernel has hard-coded that. Actually, theoretically, I should, for the views, extract that. Has hard-coded Ultra Spark, whatever, 2 or whatever. Also this put some cache methods to our benchmark. So architecture, Spark, and I found this rather silly because historically, so where do we have wait, this is not in kconfig, that is in, I had make for either arch. Here, so it's either version 8 for 32 or Ultra Spark. So, and that kernel doesn't even have a way to change that. And the x86 kernel historically had, what would that be here? So they had like stuff like Pentium, whatever. Yeah, 32, 64. Why do they even have that here? They once upon a time had actually config options. I wonder if they removed that for like even transmeta or stuff. If they have not removed that by now. So historically we didn't change that much, right? Because Linus Torvalds says like, yeah, don't optimize your kernel so much, it might randomly break, and no warranty. But yeah, we are our own warranty, right? And I'm pretty sure I had some issues like 15 years ago. Maybe also we didn't, like we were young and naive and stuff, we didn't understand everything yet, and so on. Because of course you should not use MMX, SSE, AVX instructions in the kernel and stuff, but the kernel nowadays has actually what did I want to... So the kernel is already built without AVX whatever for the most part. Now here is also, they have cabled, that is new. Oh wait, I grabbed Makefile. Okay, whatever. So this is of course taking care of most of the stuff of disabling features, because for performance reasons you don't want to save all this context. So I'm surprised actually that basically just building the whole kernel with, in my case, Senver 3 or so, gives such a performance speed up, which is certainly amazing. Let's actually basically check PowerPC, another popular architecture. Actually, they have Power 8, so that is more than the x86 kernel has, or the. Okay, but there you see they don't even allow to choose you. Actually, wait, they have generic CPU. Apparently, they also have. So if you get a little Indian, which we also tested the other day, you get Power 8. Otherwise, you get Power 4. Do they have an option for? Generic whatever. Nah. What did they config? Generic CPU? Why do they not have? Okay, they then tune for. That is interesting. That is so funny that the PowerPC people, I mean, you also can't change it the most for some reason. But they tried to optimize it for Power 10, 9, or 8, depending on what your compiler supports. I mean, it's a little bit, yeah. That also means you get that for the T2 build. Where is even... Anyway, okay, back to x86, what most people are using here. Maybe they have a... here they have that. So we had x86 and stuff. So for the irony is, I mean, sure, so there are not that many instructions, but there are also, I wonder what the compiler generates. We could, of course, what we at times sometimes do, object dump that and analyze that. I wonder if they generate modern bit manipulation instructions and stuff. So for 32-bit, ironically, we have such a diverse set here, even of very rare WinChip and transmitter cruise and efficient, which of course next to nobody has except I in my collection, previous videos, or even freaking WinChip 3D, which was my second CPU ever. But for 64-bit, they don't have such. For 64-bit, they until recently only had Athlon. Where do they even have? So all those are here. They probably are. They have depend x86-32. So we have P4. Here of very cryptic MP5C. Gotta love this cryptic config name, right? M-Core 2 or New Xeon Atom or generic. That is of course not much, right? So it's basically, I'm actually surprised that we get such a performance uplift, up to 5%. So the Linux kernel rebuilding time 1% faster in my case here today. And this should even take out, or not only should, this takes out what I otherwise really hate, this DDR5 memory training and other CPU boosting behavior of whatever random BIOS initialization stuff the modern BIOS is doing there, which I totally hate, previous videos, because I rebooted this with kexec, right? So this kernel is booted without going through a BIOS post cycle. Previously I had on this Ryzen 7950X workstation, I had for long, I pasted it previously for quite a while, maybe 17 days, plus minus. I had the previous kernel running for 17 days or so, and then kexec this kernel without a BIOS power on self-test DDR5 memory training. So there should not be any variations in memory speed, obviously, because the memory controller was not reinitialized and stuff. So yeah, it is a super simple stuff. Just wanted to give it a little bit of background, and I'm sure I had issues with that. So by the way, previously, but for today this works. And unfortunately, we kind of need to retest because the only constant is change and regressions and unit testing. Previous video there, more main channel. And I don't want to break all my T2 builds. So for now, I will only do this for architectures that I personally booted. So I will go forward. Oh, so I didn't commit this yet. I will only enable that. So what changes here is also adding this for our kernel wrapper, because we wrap compiler in T2 to automatically transform all those optimization options. And I will only do that for architectures where I tested that. So for example, UltraSpark, the next time I switch on the Niagara 4, Sun T4, Sun Microsystems T4-1, Niagara 4 T4 CPU, I will test that. By the way, I wanted to check, so yeah, we will, whether it boots and so on, right? I don't want to break all our 30 architecture combinations with this premature untested optimization. So I will probably release that. So Firefox 11 minutes. So 11 minutes I gave you this summary. Okay, that is surprisingly not that much faster. That is only 4 seconds. But yeah, this is not that embarrassingly parallel. But yeah, it is. I mean, this is of course not as amazing. But at least faster. But otherwise, you need to overclock quite a bit your CPU memory to get 4 seconds. Is still 4 seconds. The reason that's probably not that much faster is that Firefox has a very long single-threaded compile time. So LVM Clang and the Linux kernel are much more embarrassingly parallel. Most of Firefox is too, but there are 4 minutes or whatever Rust and stuff, link time optimization runs. So this is kinder maybe to expect it, so that other stressing the kernel much more, context switching and whatnot. So yeah, amazing. So up to 5, I mean, this is maybe even more, I mean, with all the recent optimizations, right? Previous video, Maple Tree, was it is it lazy RCU or what was the other? A generation. I think was it multi-generational? Multi-generational, recently used. Or was it not? Was it not too different? Yeah, multi-generational, last recently used Maple Tree. So yeah, with all this performance, it's of course crazy how much the build time. I mean, 5 seconds here, 10 seconds here, some memory overclock, undervolting and stuff after a while. That is of course amazing, especially for me. Rebuilding everything, that is of course nice to see. So I will run this, of course. Maybe we should. We will see how much will break. So I'm just up 2 hours and so yeah, just rebuild here. KCC, GCC. 17 o'clock today. So the next release will include that. I wonder, should I? Yeah, maybe I only enable. I mean, most people are only enabling that for PowerPC. PowerPC x86. Most people anyway build x86. So yeah, all the other tests stuff will be tested next. PowerPC and Spark. That is of course a thing if you support 30 architectures. Oh, I leaked you some MAC addresses. That was clever. Maybe I should not have additionally mentioned it. Anyway. There are some access point addresses and stuff. Anyway, I'm happy. I make another video, so I will commit this soon. Also, T2 is getting in an amazing shape, right? KExec, performance, packages, fixes, updates. It's just amazing. One more thing to share. So I will be back live in another minute for some bootloader discussions. Don't forget to share, like, and subscribe. I hope you learned something, found it interesting. Have a good day or night, and see you in a minute.